Hi everyone. Let us solve this problem from CSIR NEET exam. Question is from real analysis B part. Okay, so one of the option will be correct. So this question is let Gn of x is nx upon 1 plus n square x square where x belongs to this interval. Which of the following is true as n tends to infinity? So options are given as follows. Gn tends to 0 pointwise but not uniformly. Gn tends to 0 uniformly. Gnx converges to x for all x belongs to this interval. Gnx converges to x upon 1 plus x square for all x belongs to this interval. So let us see how to solve this. To solve this problem, let us first of all find out what is limit of gn of x as n tends to infinity. Right? So we have given gn of x which is equals to nx divided by 1 plus n square x square. So to find out its limit as n tends to infinity, gn of x which is at limit as n tends to infinity, nx divided by 1 plus n square x square. So whenever we find limit of this type of term, we always think of what is highest power of the term which is that denominator. Okay, so here highest power of n at denominator is 2. So we will divide numerator and denominator by n square. So limit as n tends to infinity, nx divided by n square, 1 plus n square x square divided by n square. So by separating limit for numerator and denominator and cancelling out common terms, at denominator we will separate denominator n square. So we can write x upon n divided by 1 upon n square plus x square. So by taking limit, we can see that limit of numerator as n tends to infinity becomes 0. So anything 0 upon anything, that is 0. So value of this will be 0. So clearly here we got limit as n tends to infinity, gn of x which is equals to 0, which is nothing but small g of x. So clearly as we have found limit of gn of x as n tends to infinity is 0, therefore option C and option D cannot be correct, as here it is given limit of gn of x is x as n tends to infinity and limit of gn of x is x upon 1 plus x square as n tends to infinity. So both options C and D are discarded. So only remains to check from these two options which one is correct. So to check this, we're gonna use one theorem. That theorem says, suppose limit as n tends to infinity fn of x is f of x for all x belongs to some interval e. Let mn be the supremum of all these absolute values, that is fn of x minus f of x for all x belongs to the interval e. Then this theorem says Fn converges to F uniformly if and only if this Mn converges to 0 as n tends to infinity. So let us see how to apply this theorem. Let us find out what Mn will be. So for this, Mn will be supremum of x belongs to interval 0 to infinity where it is close at 0, gn of x minus g of x, that will be supremum of x belongs to close interval 0 to infinity modulus of nx upon 1 plus n square x square minus 0. So we have to just find out supremum of x belongs to the interval 0 to infinity mx upon 1 plus n square x square. So we want to find out what is supremum value of this function, right? So for this, we're gonna use the technique of finding maxima minima. So let us see how we can do it. So let f of x which is equals to nx upon 1 plus n square x square, whose maximum we want to find out, and that maximum should be belongs to the interval 0 to infinity. So to find out this, let us find out first f dash of x. So by u upon v rule, it will be 1 plus n square x square the whole square. 1 plus n square x square as it is. Derivative of nx with respect to x, that will be n, minus, by keeping nx fixed, derivative of this term, that will be 0 plus 2nx, 2n square x. So if I'll open this bracket, we'll get n plus n cube x square minus 2 times n cube x square divided by 1 plus n square x square the whole square. So we can see that their powers are same. So it will become n minus n cube x square divided by 1 plus n square x square the whole square. So this is f dash of x. So we know that to find out stationary point for this function by equating this derivative to 0. So f dash of x is equals to 0 if and only if this numerator will be 0, that is n minus n cube x square, which will be equals to 0. So we have found f dash of x is equals to 0 implies n minus n cube x square is 0. If I take n common, I can write it as n square x square equals to 0. This implies 1 minus n square x square has to be 0. N cannot be 0. Why? Because n is from set of natural number. So I can factorize it and I can write it as 1 minus nx, 1 plus nx, which is equals to 0. This implies either this factor is 0 or this factor is 0. So from which I can write x can be 1 by n or x can be minus 1 by n. But clearly, since as I want to find out maximum from the interval, as x should be belongs to interval 0 to infinity, so x cannot be minus 1 by n. So this possibility we have to discard. So only we will consider this as one of the stationary value. Now at this point we can check function has a maximum. So we need to find f double dash of x. We have already calculated f dash of x, which was n minus n cube x square divided by 1 plus n square x square the whole square. I'm not calculating f double dash of x here. You can cross check its value. It will be like this: minus 6n cube x plus 2n raised to 5 x cube divided by 1 plus n square x square whole raised to 3. So to find value of this at x equals to 1 by n, by putting x as 1 by n in this, f double dash of 1 by n, that will become minus 6n cube into 1 by n plus 2n raised to 5 1 by x raised to 1 by n raised to 3 whole divided by 1 plus n square 1 by n the whole square whole raised to 3. So it will become minus 6n square plus it will become 2n square divided by 1 plus 1 whole raised to 3. So which we can see that minus 4n square divided by 2 raised to 3. So which we can see it is minus n square by 2. So clearly n square will be since n is a natural number, it will be positive. N square will be a perfect square of any number it is positive. So value of this will be always negative. So which is always less than 0. So by the test of maxima minima, you can clearly say that x equals to 1 by n is a point of maxima of f of x. Thus we have found x equals to 1 by n is point of maximum of f of x, which is nx upon 1 plus n square x square. And this point of maxima is between the interval where x belongs to the interval 0 to infinity. So let us find out Mn, which is supremum of x belongs to the interval 0 to infinity, which is nx upon 1 plus n square x square. So that means we want to find out value of this function at x equals to 1 by n. So by putting this n x equals to 1 by n in this, so we will get 1 plus n square, 1 plus n the whole square. So that will become 1 upon 1 plus 1, that is 1 by 2. So we are getting Mn as a constant sequence of 1 by 2. So clearly we can say limit as n tends to infinity Mn, since it is a constant sequence, its limit will be also constant, that will be 1 by 2. So here we have found limit as n tends to infinity Mn, which is equals to 1 by 2, which is not equals to 0. So by using theorem, but our theorem says that Fn converges to F uniformly if and only if Mn tends to 0 as n tends to infinity. So by this theorem, we can say that Fn does not converge to F uniformly. It is pointwise convergence. It is not uniform convergence. Thus, we can discard option B and we can say only option A is correct.